Assalamualaikum and hi, my name is Muhammad Hanif NAZMI. Our title is Spectrophotometric Determination of Total Vitamin C in Orange Fruit at Koya area, Kurdistan region, Iraq.
Our group members are Hanif NAZMI, NURUL JANNAH, Ardini, and also NISA FATINI.
The spectrophotometer main operating principle is that it measures the amount of light that is absorbed or transmitted by a sample at specific wavelength. The concentration of the absorbing in the sample relates directly to the amount of light that is absorbed or transmitted based on Beer-Lambert law. A sample absorbent or transmittant can be measured using a spectrophotometer at various wavelengths. The transmittance and the absorbance are measurement of how much light is transmitted and absorbed by the sample respectively. Then, a plot of the transmittance or absorbent as a function of wavelength is created. This is known as spectrum. Scientists can identify the components of the sample and measure their concentration by studying the spectrum. In several disciplines, including chemistry, biochemistry, and medical research, spectrophotometers are widely used. For example, spectrophotometers are used in chemistry to measure the concentration of specific molecules in a solution and to analyze the chemical makeup of substances. Spectrophotometers are used in biochemistry to investigate the characteristic of enzyme, proteins, and other biomolecules. Spectrophotometers are instruments used in the investigation of drugs characteristic and the measurement of specific chemicals in urine and blood.
For the sample preparation, 10 grams blended sample was homogenized with 50 ml of acetic acid solution and was transferred into volumetric flask and shaken gently until the homogeneous dispersion was obtained. Then it was diluted up to the mark by the acetic acid solution, and the solution was filtered by adding a few drops of permeable water until the solution became colored. A few drops of thyroruthia solution were added to remove the excess bromine, and clear solution was obtained. 2,4-dinitrophenyl hydrazine solution was added with the oxidized ascorbic acid into the solution. And lastly, total vitamin C was determined by using spectrophotometry.
Discussion. From the research paper, the concentration of ascorbic acid was determined by firstly determining the wavelength of maximum absorbance of standard ascorbic acid, lambda max. This is the spectrum obtained, and the lambda max was 280 nanometer. Next, calibration curve of concentration versus absorbance of 6 standard solution of ascorbic acid at 280 nanometer were constructed. By applying Beer's law, the concentration of ascorbic acid in orange fruit can be determined by using absorbance value of ascorbic acid in orange fruit at the same wavelength. Thus, the concentration obtained is 4.337 mg per 10 gram.
So, as the conclusion, lambda max that has been determined is 280 nanometer with the concentration of ascorbic acid in orange fruit is 4.337 mg per 10 gram. So, orange, tangerine, sour orange, lemon, green pepper, and tomato are just a few of the citrus fruits and vegetables that rich with vitamin C that may be found in the Koya area. So, vitamins aid in sustaining a healthy diet in people. They play a crucial role in the formation of particular coenzyme which involve in the metabolism and other specialized process. Among the vitamins, vitamin C, which is ascorbic acid, is the crucial micronutrient needed for the body's regular metabolic activity.
Assalamualaikum and hi, my name is Muhammad Hanif NAZMI. Our title is HPLC UV Quantitative Analysis of Acrylamide in Snack Foods of India. In chemistry, biochemistry, and other related science, high-performance liquid chromatography (HPLC) is an effective analytical technique that is frequently used. A mixture of compounds are separated based on their unique physical and chemical characteristics, such as size, charge, and polarity. Different chemicals in a mixture will react differently with stationary phase and a mobile phase according to the fundamental element of HPLC. The mobile phase is normally passes through a column of stationary phase that has been filled with stationary phase. Based on how they interact with the stationary phase, the various components of the mixture will be separated as the mobile phase passes through the column. Reverse phase and normal phase are the HPLC equipment types that can be utilized. For normal phase, a polar substance serves as the stationary phase in the HPLC method, and a non-polar solvent serves as the mobile phase. For reverse phase, a non-polar substance serves as the stationary phase in the HPLC method, and polar solvent serves as the mobile phase, but for this experiment, we use normal phase. Ultraviolet as detector. Light is used by a UV visible HPLC detector to examine materials. The analyte can be determined by measuring the sample absorption of light at various wavelengths.
The sample preparation procedure includes deflating of sample with dichloromethane and ethanol, extractions of aramide with acetone, and cleaning by solid phase extraction cartridges using the modified method. For the deflating of the sample, finely ground and homogeneous 10-gram potato chip sample was deflated twice by adding 50 ml dichloromethane and 5 ml ethanol and 50 ml dichloromethane alone. The sample then shaken vigorously for 2 hours at room temperature. The mixture then was centrifuged at 3000 and 1500 rpm for 20 minutes at 15 degrees Celsius, and the supernatant produce was discarded and precipitate was dried in the vacuum oven at 50 degrees Celsius. For the extractions of aramide with acetone, 20 ml of acetone was added to the deflated sample and was shaken vigorously for 30 minutes. The sample was placed in an ultrasonic water bath at 40 degrees Celsius for 20 minutes and followed by centrifuge at 3000 rpm for 25 minutes at 15 degrees Celsius. The solvent was filtered with filter paper and the filtrate was evaporated under flash evaporator to dryness. 2 ml of mobile phase for HPLC with the ratio 40:60 was added and shaken to dissolve the residue. Lastly, for the cleaning by solid phase extraction cartridges using modified method, the aqueous solution was purified using solid phase extraction tubes. The aqueous solution then was injected to the column using 20 microliter injected loop.
My name is Ardini. For discussion part, this experiment using an isochromatic pattern by 40% HPLC grade water and 60% acetonitrate. The retention time obtained is 1.6 minutes. Acrylamide concentration was obtained from snake food samples which ranging from 0.37 ppm to 6.39 ppm. For potato chip snack food, from this experiment, it shows that potato chip has high concentration of acrylamide, which ranging from 1.27 ppm to 5.31 ppm. So there are two types of potato chip which consist of organized cottage industries and also from unorganized cottage industries. For organized cottage industries, the concentration of the acrylamide in the potato chips, which is Lay's, is 2.59 ppm, while the concentration of acrylamide in the unorganized cottage industries is higher, which is 5.75 ppm, which shows that unorganized cottage industries will use a higher amount of acrylamide which are not good. So based on the public health, it states that if too much of acrylamide concentration in body, it can affect nervous system such as muscle weakness, numbness in hand and feet, sweating, and tendinous and clumsiness. For the concentration, the unorganized cottage industries contain high amount of wheat 2 to 3 times higher than chips produced from organized industries. The high amount of the acrylamide may due to unscientific processing conditions such as temperature and extended frying time, and also repeated use of frying oil. So next is chromatogram. Based on this experiment, HPLC chromatograms for potato chip sample are used to determine the retention time for the acrylamide in sample. And the last one is the retention time. The retention time obtained is 1.696, which is the highest value if compared to other types of snack food that has been used in this experiment.
Conclusion. From the study, it was shown that analysis of acrylamide in potato chips Lay's can be done by using HPLC method. From the chromatogram, the retention time of acrylamide in potato chips is 1.6969 minutes. The concentration of acrylamide content in potato chips Lay's are 2593.35 and 1064.30 microgram per kilogram for both Magic Masala and Classic Salt Lay's. From the research paper, the highest content of acrylamide was detected in potato chips from unorganized food processing units. Thus, food processing industry should focus more on material selection and processing methods to have lower level of acrylamide. That's all for our presentation video. We hope our case study bring more knowledge towards future studies on high performance liquid chromatography and UV visible spectrophotometer. Thank you.